Hi everyone, today we will talk about question number 22 from 2019 Standard Maths exam. This question came from one of the favorite topics of examiner and my favorite topic from trigonometry. And this question was a bit of a complicated type of trigonometric questions because the easy ones would ask you for simple shape. One shape would be given, whereas there would be a kind of questions which are combination questions. So you should check this section out, which talks about these type of combination questions. This question came from 4.4.1, so type 1. Uh, so basically, there are two shapes that are joined together, and then you need to work out your answer. So let's open this question. So you're given two right angle triangle, A, B, and C, A, D, and C. Now, what you need to work out is this angle theta. And it's not going to be obviously as simple as you can't work it out only from triangle A, B, and C. Otherwise, there was no point of giving this triangle. So let's see what we can do about this. Take out this question. So first thing you need to know is for any right angle triangle, so if I draw this A, B, and C, for any right angle triangle, you need to know two things. If you know two things, you can work out all the other things. Either you need to have an angle given to you and length of one side given to you, then you can work out pretty much all the remaining things in there. If that is not given to you, then you need to have, if this is a right angle triangle, then you need to have at least two sides given to you. If you know value of two sides, any of the two sides, then you can work out everything else, all the angles and the remaining side as well. The problem with ABC is that you're only given one thing, which is just one length of AB. You're not given another angle. So you can't directly work out what is theta here. But if you look at triangle AD and C, you are given two of the things, which means you can work out pretty much everything about this triangle. And the thing that we are most interested in working out is this side AC. This is what we need to work out. Why is that? Why do we need to work out this? Well, you can try working out the angle, but what's that going to lead you to? Even if you know this angle, you're not going to be able to solve this theta value. So even this angle is not going to help you. So the only thing remaining is you need to know what AC is. So how do you work out AC? We will use Pythagoras theorem, which is simply the hypotenuse. Hypotenuse is the side facing the 90-degree angle. AC square is equal to 2.5 square plus 6 square. If you solve this, you will get the value of AC, which will be 6.5. Now we know AC is 6.5. Now for ABC as well, we know two things, length of two sides. So all we need to do now is apply one of the sine, cosine, or tangent to work this out, the angle theta. Now, if you check out the StudyNinja site, there's a shortcut to remember the formula for sine, cosine, and tangent. It is so ka towa. So first you need to work out what are each of the sides. So the length that is adjacent to the angle in consideration is called adjacent. The length facing the 90 degrees is called hypotenuse. The length opposite the angle is called opposite, as the name suggests. So in this case, what this is saying is cosine. You apply cosine on adjacent over hypotenuse. That's what it's saying. So in this case, we know adjacent, we know hypotenuse, so we can apply cosine. So what we will do is cosine of theta is equal to adjacent over hypotenuse, and adjacent is 4.9 divided by 6.5. If you work this out, you will get your angle, which is 41.5 degrees.